Welcome to Tesla's Experiments. This is Roy back again. Right there what you're looking at is extended top load. And it's a transistor Tesla setup. Even though Tesla didn't have transistors. It's a shame that he died right before it, I think like a year before they were invented. But it'd be a good day if you could see that happen. Really good. Unjust for the Tesla man. So let's go over here and take a look. What we have here is a 2N3055 transistor. If you look at my last video, I show how it's hooked up. Not using any resistors, capacitors, or diodes, nothing. So I got 24 volts, got primary, secondary, suspended top load. This is my receiving coil. Primary's up towards the top. Got your top load. I do have the wire running up from the top of the secondary on both of these guys. This one runs up. It does touch the top capacitor and just dies up there. And then this one, not only does it touch the capacitor and goes up, but it comes back down. And I had it hooked up to this capacitor plate that I made. It's a 1/4 inch thick glass with a piece of foil tape on bottom. Right here you can see I got the top of the secondary hooked up. I got another alligator clip coming off the bottom, and that comes over to another one that I have made out of plastic. I wanted to see what the difference is between these two. We'll check voltages on that and that using the voltmeter. I got 3 different grounds going right here. This one here that the bottom of the secondary is hooked up to. And by the way, I'll show you a few little tricks here. This one here is earth ground, and this one here is steel rebar with a 1/2 inch copper tube around it. This one here is just a steel rebar in the ground. This one here is a PVC. So we'll check the differences here. Alrighty, let's fire this thing up. Bam, voila. Grab the light bulb. Let's go ahead and check. Not good. Let's unplug and then plug back in. I'm just going to say Houston. Houston. The ground's unplugged. Let's plug that in. And then let's plug in the, there we go. Fire in a hole, guys. I also have, well, let's unplug this and let's look at the oscilloscope. Both are just sitting there free. They're sitting on top of that aluminum toroid that's doing nothing. And you can see they got something going through them, but not much of anything, right? They're not connected, by the way. Let's go ahead. I'll go ahead and show you what happens when I kick it on. Look at what's going on. We're getting action. Let's go ahead and grab the bulb. Let's check the side going on up. We got power up here because we got the wire there. You got your top load. You got the wire up top, and it'll keep going. Keep going as long as you have that wire going. Now over here, let's go ahead and check. Let's bring it on over. Really? See, I touched that. These things are so sensitive. I touched that top there with my arm, and it short-circuited the circuit. So I could bring that over. I got it lit over here on the receiving side. Should stay lit a little bit up in there. You can see that it's got energy up in there, coming down. Not down there. Let's check the capacitor. Lighten up the bulb. This one here. Let's check this one again. Let's see. So you got, I like to check both ways. One is I got the bottom touching. There it is. I just see that light up. It's lighting up. Just being a little sensitive right now. So that's just connected through here. You can see that it's lighting up good. Up the wire, you can see that it'll react to it there, light the bulb up. Alright, the capacitor, not the capacitor, the transistor lights up. And I gotta say, the transistor is the culprit that creates this frequency, but without the primary acting like a well, the primary supporting starting the power, the secondary receiving the power, and then the power goes up and down. And on the bottom stroke from this bottom of this secondary here is the start of the transistor turning on and off at the base. It's the signal input. So I gotta say, it's the trisome there. So you can actually create another trisome is what I'm thinking. It doesn't have to be a Tesla coil. As long as I have a tickler, I could, you know, you need a power, a magnetic field, another copper wire for a tickler, and then you can create something else that could be solid. So I want you guys to know that. So let's go ahead. Anything else? Any other light bulbs? I don't see anything happening on this one. Maybe in the dark. Let's go ahead and take the voltmeter. All right. So we got the voltmeter here. It's, I wish it had light. Does it have light? No light. So we're going to hook up the positive over here. Okay, and we're going to, what's showing up? You got in volts, okay, 0 and change. So I'm going to go here and touch just this ground here. All of a sudden 2.3 volts show up. Okay, let's go over to DC and see what we got. We got in DC, we got 36 volts and change, okay? Now it's me just touching ground. Let's touch this other ground. And we're at 25 volts. So I told you that these are different. Now we're going to touch the bottom of the secondary with ground, and we got 35 and change. Okay? So that's in DC. Let's go back to AC, because I think that this probably just fell apart. I might get a better. Okay, in AC I got 136 volts connected to the bottom of the secondary and ground. This is in AC. Okay, let's go over to this other ground. And in AC we're at 5 and change. I think this connection here is not being that good. So back over here we're at 119. I'm just touching that. And if I move over grounds, we're at 5.65. The other ground is 5.7. If I touch the other capacitor plate, and then AC, we're at 14 volts. If I go over to DC, touch the capacitor, other capacitor plate, I got 100 and climbing volts, and that's collecting through that other plastic capacitor plate. The positive side of this is on this capacitor plate, and right now we're charging capacitor plates. So guys, what you're seeing here live, because I didn't know this does this, but we're charging these plates right now, which I'm not going to make sure I don't touch these suckers. So that plate, glass, and that plate there is charging. Now that plate just gave out. So it got up to like, I don't know, what was that, like 600? How high did that go up to? I'll check back on the vid. So, let's see if we even have anything working here. Yeah, we do. Because it seemed like just it gave out. That was pretty interesting. Okay, so let's go back to checking this. We're in DC. That was a DC climb we just had. Pretty interesting. That was so interesting there. So, now we're back on AC. And we're at 120 something. Let's move out of here and come over here. We're going to connect the positive side of the voltmeter to that capacitor. I'm going to connect that capacitor to just touch it to the ground in the bottom of the secondary. And you can see it's climbing, or climbing. So it's 118 volts in AC. If I switch it over to DC, it is 21 volts. Back to AC. And 12 volts. This is touching another ground now. I'm at 1 volt. Or is that 1,115 volts in AC? I'm touching the other ground. I'm going to touch this ground here. We're at 1.132. I'm confused. Is that 1,189 volts? Let's go back to this one. When it's beeping like that, it only does that when it's over 1,000. That was very strange. This is digital. You know, they only are good as they can be. Well, for right now, let's do one more test. Let's go ahead, and we have still hooked up to that far capacitor, and we'll touch the top of this wire, and we're at 17 volts. Now we're going to go over and touch the other wire. Okay, we're at nothing. Touch the other wire, and we're at 216 volts. This is AC. Let's go to DC, and we're at millivolts. So we're not getting nothing in DC. The thing is so oscillating up there. There ain't no way to get DC. But at AC, son of a bitch is kicking up there to 200 and something. So we got some juice coming through the top of this. You notice that with this tower here, let me turn this off. You notice that, well, let's check one more thing. Let's go ahead and put a bowl of water on top of this plate. And let's see with the light bulb what comes alive. Bulb's still lighting up here. Nothing there. Nothing.